morning, children. So yesterday we had talked about Kirchhoff rules, and then we tried to solve a problem. One of the problem was given to you yesterday to solve as a homework. So answer for that is I1 is equals to 2 by 3 ampere and I2 is equals to minus 1 by 3 ampere. And now since you have done two questions, you can do some other questions from your side books also, refreshers also. Now we'll talk about the next topic, that is Wheatstone bridge. Now what is a Wheatstone bridge? First thing is that it is named after a scientist, Wheatstone. And it is an arrangement of 4 resistors like this. It's an arrangement of 4 resistors like this, in which across one of the diagonals, so let us name them as A, B, C and D. One of the diagonal across it is connected a cell or a battery, or you can say a source of potential difference. This arm is known as battery arm. Between the other 2 points, that the other diagonal, across the other diagonal, a galvanometer is used. You can connect it like this. See, I can make galvanometer from outside, connect the galvanometer from outside. Cell can be connected from inside, that is immaterial. So, across one of the diagonals, a source of potential difference is connected. Across other diagonal, a galvanometer is connected. Now, galvanometer is a device to detect current as well as it will detect the direction of current also. About galvanometer we will be doing in unit 3rd also in detail. Let us name these resistances. Say R1, R2, take this as R2, R3 and R4. We'll take it according to the NCERT book. We have taken these resistances, so you can, when you go through the book, it will be similar to circuit diagram. Now what we are going to do? See, we'll find out that there are certain questions in which using Kirchhoff law all the time will be a lengthy process. Rather, if we use the concept of Wheatstone bridge, the questions problem solving will become easier. How? When you see the question in the form of a Wheatstone bridge, a condition can be applied. Now, which condition? The condition is then when no current flows through galvanometer. No current flows through galvanometer, then R1 upon R2 will be equal to R3 upon R4. What is the condition we are going to use? Or first we'll derive. Later on this condition can be directly used in solving the problems. What is the condition? When no current flows through this arm, then the ratio of these arms R1 upon R2 must be equal to R3 upon R4. Or we can do it with the other way around also. If ratio R1 upon R2 is equals to R3 upon R4, then no current will flow through the middle arm or through the galvanometer. Now how you do? We will use Kirchhoff's law. See, this proof we can do by simply using the concept of potential difference also and using Kirchhoff law. But we'll be using Kirchhoff law because in examination sometimes it is asked. In general also, prove the condition of Wheatstone bridge, that is R1 upon R2 is equal to R3 upon R4. And sometimes it is asked using Kirchhoff's laws. So if we are doing it with Kirchhoff law for both the question, you can give the same answer. Now how we are going to prove this? See, no current flows through. So first what we will do is we will take two closed circuits and write the equation using Kirchhoff's laws. Let us consider the closed mesh A, B, D and A. A, B, D and A. First thing what you have to do, I have given you the circuit diagram. Second is to draw the direction of currents. So let us consider the currents in different branches. Let the current flowing through the arm R1 is, say, I1. Through R2 is, say, I2. Now when the current will reach at the point B, it will have two paths. One towards R4 and a part towards IG. This concept I can take here also. At one of the corners we will have to take. So this will be IG from galvanometer. Now how much this current will be equal to? I can take I4 also, but since as I have told you, put the least unknowns in the equation. So we will try to write down in least unknown terms. So this can be written as I2 minus IG. Now this IG is going to reach here. I1 is coming from here. These two currents will meet here. So at the junction, according to junction rule, this current will now be equal to I1 plus IG. In this way, we have drawn the various currents in the circuit. Now the third is we have to identify the closed loops or closed meshes. So one will be this, can be taken as this one. Another is this one. Next is, you can take this one also. I can take this also. I can take this also. So there are various options for me. So, but I will be taking only two equations because I have got only now two unknowns, I1 and I2. In any case, for finding out the condition of balanced Wheatstone bridge, IG has to be 0. See, when IG is taken to be 0, the bridge is said to be in balanced condition and this ratio will follow. So let us first find out the condition. Closed mesh ABDA. Again we'll take anti-clockwise positive and clockwise. So clockwise will be taken as positive, negative, and anti-clockwise will take positive. In all the question you should take only one assumption. Now in ABDA, we'll start from say I1. See, just see how it is going. Now forget about the other circuits, only this part. It will go like this. See, this is anti-clockwise. So I1, R. Come to this branch. How it is moving? Now it will go like this. So this is clockwise. Minus IGG. Third branch. It is going again clockwise. Minus I2 R2 is equal to, there is no source of EMF, is equals to 0. This is my equation number 1. Come to the second circuit. Closed mesh. Mesh itself means closed. B, C, D, B. The same convention. We'll start with I2. From here we can start with R4 or any of these two or any of the three branches. So we can start from here. Let's see. So this is now, just see how it is moving. It is clockwise. I2 minus IG into R4 as it was clockwise, negative sign. Then come to this branch. It is moving anti-clockwise. So it will be positive, plus I1 plus IG into R3. Then this again anti-clockwise. So plus IG into G. And again there is no source of potential difference in this branch. This will be equal to 0. Now we can open the brackets, or we can leave here and just put the condition first. What condition? Take it as equation number 2. What condition? No current flows through the middle arm. If no current flows through the middle arm, that means IG is equals to 0. This is the condition of a balanced Wheatstone bridge. Put it here now. I'll put IG is equal to 0 in both the equations. I1, R1, this is going to give me 0 now. Minus I2, R2 is equals to 0. This is going to give me I1, R1 is equals to I2, R2. This you can take equation number 3rd. Now come here. Put IG is equal to again 0. So this is going to give me 0. This is again going to give me 0. This term whole will give me 0. So I am left with minus I2 R4 plus I1 R3 is equal to 0. This is going to give me I1 R3 is equals to I2 I4. Take it as equation number 4. Dividing equation 3rd by 4th. Equation 3rd by 4. What you'll get? I1 R1 upon I1 R3 is equals to I2 R2 upon I2 R4. This is going to give me R1 upon R3 is equals to R2 upon R4, implies R1 upon R2 is equals to R3 upon R4. This is the condition for balanced wheat stone bridge. Now doing this derivation, you will do this derivation first. Then you will do example 3.8. This is a solved one. And then you will do exercise 3.9. This is unsolved. This is a solved example. Do these two exercises and then we'll do one or two more questions based on we stone bridge tomorrow. Yesterday's question which I gave you, the answer is I1 is equal to 2 by 3 ampere. I2 is equals to minus 1 by 3 ampere. And if you are not able to do solve it, you can ask, you can send the message. We'll do it in the class itself tomorrow. Thank you.